In this section, we are talking about how to solve an initial value problem using a Laplace transform. But before we are able to do that, to apply the Laplace transform as a method of solution for initial value problem, firstly, you want to be able to do derivative transformation or transformation of derivative, which means how to convert an equation which is in terms of t into a representation in terms of s as a Laplace terms. In order to do that, we will list some of the laws that we can use in order to transform the derivatives from terms of t to terms of s. First, the Laplace for a double prime derivative in terms of s, so you are moving the y double prime in terms of t to be in terms of s, that will translate into s squared multiplied by y of s minus s multiplied by y of 0, usually given through the initial value problem, minus y prime of 0. And the Laplace transform for a y prime of s equal s multiplied by y of s minus y of 0. And the Laplace transform for y of s equals y of s. Keeping those terms in mind, you are able to change any regular first order, second order derivative in terms of Laplace, or you will be able to do a Laplace transformation for that equation and eventually being able to solve it. As usual, we don't want to talk a lot of theoretical explanations. We will jump right into the example to clarify that concept. Assume that you have an equation, first order derivative, y prime minus 4y equals 1, and you have an initial value of y of 0 equals 1. To solve that using the Laplace transformation method, you want to take the Laplace for the whole equation. Let's take the left term, Laplace transform of y prime minus 4y of s equals the Laplace transform of the right hand side of the equation, which is 1 in terms of s. Now we can say that Laplace transformation in this case has the distribution property, so you can distribute the Laplace on both terms of the left hand side of the equation. So you can say this can be Laplace transform of y prime alone of s minus 4, you can get the constant outside, no problem, Laplace transform of y in terms of s equals the Laplace transform on the right hand side as written before. Okay. Now we know from here Laplace transform of y prime equals s multiplied by y of s minus y of 0. We have a value for y of 0 that we can compensate, but keep it as y of 0 for now for demonstration purposes. Minus 4, Laplace of y of s is y of s equals Laplace transformation of 1. If you remember the table from the last lecture, Laplace transformation table from f of t to f of s, 1 becomes 1 over s. Let's change the color. Y of 0, we know from the given initial value in the equation equals 1. Okay, so now we have s y of s minus 1. We can move it on the right hand side of the equation. So let's say minus 4 multiplied by y of s equals 1. It was minus 1. Going to the right hand side will become positive 1 plus 1 over s. We have a common factor on the left hand side, which is y of s. This can be simplified as s minus 4 in parentheses multiplied by y of s equals 1 over s plus 1, or 1 plus 1 over s, doesn't matter, right? Okay, now we can say having the y of s on the left hand side of the equation gives you 1 over s minus 4 plus 1 over s multiplied by s minus 4. Okay, we know that in order to get y of t, we don't want y of s, we want the solution for this equation in terms of y of t. But now we have currently the solution in terms of y of s, in terms of s parameters. We can take the Laplace inverse of y of s to achieve the solution in terms of t. Okay, let's remember on the side from the transformation table that an f of s in the form of 1 over s minus a in terms of t will be equal to e to the power of a multiplied by t. And another term that's important and similar to what we have in the solution, a minus b over s minus a, doesn't matter, a any constant, 0, 1, 2, 3, 4, 5, doesn't matter, multiplied by s minus b. This will give you e to the power of at minus e to the power of bt. So we can see here this term is similar to the 1 over s minus a term. Here we have 1 over s minus 4, so that should be e to the power of at. A here is 4, and note that 4, not minus 4. Minus is part of the form, so you can represent that in terms of t to be e to the power of at, or e to the power of 40, plus, in the same manner, we can say plus 1 over 4 multiplied by e to the power of 40 minus 1. So in this case, after applying the Laplace inverse in here, so you have a minus b. A in this case is 0 minus 1 over s minus 0 over, or multiplied by s minus 4 multiplied by 4. This will give you minus 1 over 4 in terms of t multiplied by e to the power of 0t minus e to the power of 4t, and this can be simplified in the form that you saw in here. So 1 over 4 e to the power of 0t is 1, so this will give you e to the power of 4t minus 1, or minus 1 over 4 minus e to the power of 4t plus e, or plus 1 I mean. So this is the y of t, and this is the general solution for the initial value problem provided in this example.